So say you want to wiggle the knobs at night, but it's dark and you don't want to turn on all the lights in the room. Well, how about this? Just enough light to see what you're doing. So let's build it. First, let's look at the schematic. This module uses power from the negative rail, as not to load up the positive rail, even more so than it already is in most racks. The light is provided by 3 groups of 3 LEDs. I'm using white LEDs, which have a forward voltage of 3.2 volts, which limits you to 3 LEDs in a string on a 12-volt supply. If, however, you were using red LEDs, you could have 5 LEDs in a string, as red LEDs usually have a forward voltage of around 2 volts. The brightness is controlled by this potentiometer through these transistors set up in a Darlington configuration. You could think of this as sort of a voltage follower circuit, where the more voltage that is available at the base of the transistors, the more current the transistors can pass through R3, thereby increasing the brightness of the LEDs. The brightness can be adjusted all the way to 0 because the voltage output of the potentiometer can be lowered to less than the minimum base voltage of the transistors. In the schematic I showed diode D2. I initially built this circuit with the diode, the idea being it would give me more dynamic range on the potentiometer. But it turned out to be a bad idea, and I removed it completely from the circuit, simply bridging the spot on the PCB where we're supposed to be. Now that we've seen how it works, let's build it. I started by laying out a single-sided PCB with 2 different sizes of surface mount LEDs, so I had some flexibility in what to use. I wanted to make more than one of these modules at the same time, so I made an array of the PCBs for laser engraving onto a PCB blank. I also cut out some light baffle plates so that the LEDs would not shine directly into my eyes. Then the PCB was hung in a beaker and etched with ferric chloride. Turns out the copper on these PCBs was 3 ounces thickness, when 1 ounce thickness would have been fine. It took forever to etch, and I went through a heap of ferric chloride, but in a few days I had it. Then I cleaned off the paint I used to mask the copper for etching, and cut the array into individual PCBs, followed by drilling all the holes. Anytime I do a project with surface mount components, I always start with those. It's easier to maneuver around the PCB when the larger through-hole components are not in the way. And with the LEDs in place, it was time to mount the through-hole parts. Except for the potentiometer, I mounted everything on the underside of the PCB so it would not block any of the light. The only part I didn't have was a 30 ohm resistor, but I did have 2 15 ohms, which in series worked just fine. Now to power and test it. The lights are on. Let me kill the filming lights. There we go, much better. But these LEDs should be much brighter. Here's when I removed diode D2 from the circuit. Maybe if I wasn't using a 1 mega ohm potentiometer, it would be needed, but for this build, it was holding back the LEDs. And there we go, much brighter, even with the filming lights on, and very much brighter with them off. Now you can see why I cut those light baffles earlier. Off camera, I put together the other 3 PCBs. Now to make it more light efficient and provide a bit of a solder mask, I covered the PCBs with a white paint pen. Once the paint was dry, it was time to mount the light baffles. Using number 4 screws, because that's what I had, I found that 1 standoff and 2 washers gave the perfect height for mounting the light baffle so that it was not bent around the potentiometer. And with that done to this PCB and the 3 others, it was time to mount them in the rack. I just had to wait till the sun went down to test it. And here we are. Plenty of light to give the knobs a wiggle with, but not so much light as to wake up the entire house. Works even better when multiple units spread across the rack. And that just about does it for today's video. Hope you all enjoyed, and I'll see you in the next one.